Hey guys, we are graphing some absolute value graphs today, okay? Very exciting. I hope you've been looking forward to this. All right, so good news about these. I don't know if it's really good news. It's just kind of cool, all right? We have what we call a parent graph, okay? So if you were just being asked to graph y equals the absolute value of x, that's what your graph would look like. But you're like, I've been asked to graph something not that simple. Oh, guys, I always have the hardest time moving papers, all right? Don't switch videos. It's going to get moved, okay? All right, there we go. So you might have something out front, something being added or subtracted inside the bars, something outside the bars. Okay, so basically what we know is these two graphs are related, okay? And these numbers are going to tell me how to change this parent graph to get that graph, okay? So how do we interpret this though? Okay, so the number out front, if there is one, tells me a couple things. If it's positive, my graph opens up like the parent graph. If it's negative, it's going to be flipped around and open down, an upside down V. Okay. Also, if you have a number like 2, 3, 4, 5, 6, it's going to stretch your graph. If you have a fraction like we do here, it's going to compress your graph. And let me show you really fast what that kind of looks like. So those blue lines are the parent graph I just showed you. You can see the green has a number out front of 4, and you see how it's stretched and skinnier. The red one has a fraction out front, a 1/4, and you see how it's still a V. It's not looking as much like a V, but it is still one, right? And it is compressed, okay? So we can tell that ours is going to be compressed. So I usually like to just write myself a little note of how it's going to be different than the parent graph. Okay, so I know it's going to be compressed. And then these two numbers tell me where my graph shifts on the graph. Okay, so the number inside of the bars tells me left and right, and you do opposite of the sign. Okay, so a -2 might make me think to the left 2, but we're going to do opposite. So it's going to be shifted to the right 2. Okay, the number being added or subtracted on the back tells me up and down, and you stick with the sign on this one. So that means we are going to shift up. Oh gosh, that was weird. Up 1. Okay, so let's see what this looks like. So my parent graph, the vertex was at 0, 0, right? But this one we know is going to be shifted to the right 2 and up 1. So that is my new vertex, okay? Now, there might be some teachers who all they want to know right now is that you know that where the new vertex is and that it opens up, and then you maybe make a note that says there's going to be a vertical compression of 1/3, right? Just make that note. But there might be some teachers that want you to actually show what that compression looks like on the graph, okay? So in that case, we're going to plug in some points, okay? So I kind of want to know where this crosses the y-axis. So to do that, I am going to plug in 0 for x, right? So we're going to have y equals 1/3 times x. We're going to plug in 0 for x minus 2 plus 1. Okay, and then let's continue to work this down. So we have y equals 1/3, and then we've got 0 minus 2, which is minus 2 plus 1. Okay, if you need a review on absolute value, I'll link one in the corner, but I know that the absolute value of -2 is 2, right? Plus 1. 1/3 times 2 gives me 2/3 plus 1. And we could do our get denominators the same, all that fun stuff. But once I did that and then turned it back into a mixed number, it would be 1 2/3, right? Don't freak out about it being a fraction. We're just trying to get an idea of what our graph looks like, right? It doesn't have to be perfect, okay? So when I plugged in 0 for x, I got 1 2/3 for y, okay? Which means I'm going to start here, go left and right, none, right? 0. And go up 1 and about 2/3, so about there, okay? Now, I could plug in a point on this side as well, but another thing we know about absolute value graphs is that they're symmetrical, okay? So meaning It's the same on both sides. So if I went over 2, up 2/3, right? I'm going to also go over 2, up 2/3 this way. Now, if that feels a little confusing to you, you can always just plug in the point. If you're like, oh, the symmetrical thing isn't really working for me, okay? From here, we are going to draw our lines. Remember, it's a V. These lines are straight and look a little something like that, okay? So you see how it's a lot more compressed than our parent graph, right? But it's still related to that parent graph, okay? All right, I hope this made sense. If you need some more absolute value graphing videos, I'll link a playlist for you. Thanks.